I'm recording just so you guys know. Kendall, I love that you're online and you're still participating. Thank you so much. It's exactly what I need you to do. So perfect. Morgan, feel free, just like you do in class, to answer. And anyone online, you guys feel free to answer. But yes, so we're reviewing standard form. We talked about the Y-intercept is just sitting there at C. We talked about opposite of B over 2A is how we find the X of our vertex. What do we do to find the Y? We plug the X into the formula and figure out what the Y is. Once we find the vertex, we just opened up a lot of stuff, right? Because what runs through the vertex, you already kind of, the axis of symmetry. So if I told you your vertex is -1, 3.
Mr. Martin, we can't see.
It's supposed to be it. There it is. It's -1, 3. What's your axis of symmetry? Good. X equals -1. If I told you your A is positive, I told you your A is positive, what does that tell you about the shape of the graph? It's facing upwards. What does that make this?
The minimum.
That makes it the minimum because that's going to be the lowest this graph will ever go, and that's the Y. The Y will only have a minimum. X will never have a max or a min on parabolas because it never ever stops going left and right, right? But it does stop going down, so that's a minimum. All this is stuff, and I can change the form, right? Let's go to vertex form. What can you find in the vertex? The vertex. If you find the vertex, what does the vertex give you? Max and min, axis symmetry, yes? Now, a couple issues on this one, which we should have talked about these in standard form. What are other points that are important? We could find the Y-intercept, right? In vertex form. If I want to find the Y-intercept, Y equals 1/3 X plus 3 minus 2. If I want to find the Y-intercept, what do? Plug in 0 for X and do my, that should be squared, and do my math, yes? So 0 plus 3 would be 3. 3 squared is 9. 9 times 1/3 is 3. 3 minus 2 would be 1. Y equals 1 would be my Y-intercept. Right? If I want to find the X-intercept, what do? But why is this one a little bit more of a pain in the butt?
You have to go backwards.
Got to go backwards. I got to add 2, and do all that stuff to get my X isolated. You with me? So depending on what form they give me, I've given you all the resources to be able to find those things. And using those key components, you can sketch a graph. What's the most important point? So far, do you know how to find the vertex in every form we've done? Except for a factor, because I'm going to teach that to you today, right? And then you can use the Y-intercept, you can use the X-intercept, you can use about whether it's facing up or down to help you graph it. All these things are going to be points or key components to help you make the graph and then make decisions on what this thing should look like and what it means. You follow me? So let's go over factor form. Oh, why didn't we like standard? What is standard form not good for? It's not good. It's okay for my vertex. It's not good for my X-intercepts. Why is it not good for my X-intercepts? In order to find my X-intercept, I made my Y 0, yes. But what would I normally do here? Work backwards to try to isolate X. What's the problem? I can't isolate X because I have X squareds and X's. And so what did we say will never happen? In a second. What did we say will never happen? You can't ever combine X squareds and X's. So what do you have to do to solve this? You actually have to change this from standard form into factored form. That's why I taught you how to factor. The quadratic formula will get you the X-intercepts when something's not factorable. So when something is not factorable, you'll have to call, I always say you have to call it the big guy. So this is factorable. So I would just do same signs, two numbers that multiply to get me 6, but add to 5, 3 and 2. So you would actually change the form of this to factored form, because standard form is no good for finding the x-intercepts. You actually have to change its form. It's not necessarily just math, it's changing the form of it to factored form. Do you follow me? Yes? And then from factored form, what we talked about is, hey, this right here is going to turn into a number. And this right here is eventually going to turn into a number. And let's say, come on, give me attention. Let's say that this is x is 1. When I put 1 in for x here, what do I have to put in here? So whenever I pick an x, it has to stay that same x for every x during that time that I'm talking about x equaling 1. Can I change x to be 2? But what has to happen? I have to change all of them to be 2, right? You can't have one x in the problem being 1 and one x and the other x in the problem being a different number. If they're 1, they're all 1s in the problem. But what I can do is change all of them to be a different number, and that's how it changes variable, right? Does that make sense? So if I said x is 1, what does this turn into? 4, yes? If I put a 1 in here, this turns into 3. And what are these two numbers down here doing to each other? And when I try to find the x-intercepts, I know that my y is 0. What am I trying to say? This number, which I'm trying to make an x that would make this. Like, would this work? Would x equaling 1 get me what I want? Why not? Because it's 0 equaling 12. Does that work? So putting 1 in there doesn't work. What I want you to look at is what happened to these numbers. What is this number doing to this number? Multiplying. And what is the only way that when you multiply two numbers together, they will equal a 0? If one of these numbers is a 0, so then I look at the bubble and I go, hey, what number would make you a 0? Because if you're a 0, I don't care what you are, sorry. Anything times 0 is going to be 0. So what number makes this bubble 0? And what I'm telling you is, if you put a -3 in for how many x's? No. You have, I told you, whenever you put an x in, you have to put it in for what? You have to put it in for all of them. There could be 3 or 4 or 5 x's, whatever x you choose. So I'm telling you, if you say x equals -3 and you put -3 in here and also in here, what's going to happen to the whole thing? It's going to turn to 0. Why? Because the front bubble is going to turn to 0. It's going to turn to a -1, but honestly, I don't care what it turns to. Because 0 times anything is going to be. But not only can the front bubble turn into a 0, but what else could happen? What if this was a 0? Would I care about what this was? So what makes this bubble 0? Which means that there are two intercepts. Is that possible? Yeah, it's a parabola. Can a parabola hit x twice? Yeah. And what does this say? This says it actually hits it at -3, -2, and this parabola looks something like this. By the way, how did I know this thing was facing up? Because it was positive, right? All this stuff is coming together. Now, I don't know what the vertex was. I didn't do the opposite of B like I could have, right? But I found the x-intercepts. Now, yes? Yeah. Yep. Now, that's what they're going to, if I give you something in factored form, that's what it's going to look like. It's already going to be factored for you. That's what factored form looks like. What is factored form good for? X-intercepts. In fact, you should be able to tell them to me really quickly. What are the x-intercepts?
2, -1.
Boom, I found the X-intercepts. What does it not give me straight away on its own? I'm going to teach you how to find the vertex using that in just a minute. Okay, now what if I were to give you this? How in the world did she get -2/3? Well, here's what you're doing. When you said this, you really asked yourself, x minus 5, when do you equal 0? And in your head, you actually added 5 to both sides, and you solved this equation without you even knowing. That's what you did. You said, what number could I put in here that would make this 0? That's what you just did. Right? So when it's not so pretty and so easy, what can you do with the 2x plus 3? What are you trying to see? When that bubble equals what? Garrett, when that bubble equals what? So we're going to say 2x plus 3 equals, and we're going to use our algebra skills. To get it. Now what Caddison did was she said, hey, what would I do to get this to where if I put that equal to 0, what would be the first thing I would do? If I was made this equation equal to 0, because there's 2 intercepts, right? This first bubble's one answer. It's -3 comma what? Nope. 0. It's a Y-intercept, or it's an X-intercept. My Y is 0, yes? What would be the other intercept? Right. But you could do it in your head, Garrett. Look, think about it. Didn't you -3 and then divide by 2? So what would you do first here? No. Add 5. So what number would that be? Careful. 5/4. The way that you got that is, you really said 4x minus 5. When do you equal 0? Add 5, add 5. 4x equals 5 divided by 4. Right? So when the bubbles aren't so nice and pretty, just set each bubble equal to 0. Because that's what we're trying to find. What number, if you put a -3/2, what would a -3/2 do to this number right here? What would -3/2 do to this right here? Make it 0. And then I don't care what it does to this one. I don't even need to plug it in, because once this is 0, 0 times whatever number this turns to is 0. And what does 5/4 do to this bubble? And I don't care what it does to this one. So there are 2 intercepts. Not always, but in this case there was.
How you know when it's not?
Well, what would happen like this? Have we talked about perfect squares? How when I factor something, it ends up looking like this at the end? Well, doesn't that mean that it's x minus 3 times x minus 3? What makes this bubble 0? 3. What makes this bubble 0? 3. So how many x-intercepts are there? 3, 0. In fact, the only way that that can happen is if that is my vertex. So not only is this my x-intercept, it's also my vertex. Which means this is not only factored form, because there's no plus 0 back here, right? This is my right to the right 3 and up 0. Now, how come normal, that's only a special case, right? Yes, ma'am. No, this would be a perfect square. So it would be the same one twice, x minus 3, x minus 3. The difference of squares is the one you're thinking of, where it would be x plus 3, x minus 3. But you can only write it squared if you have the same exact thing twice. That's not identical. That little plus and minus makes it different. Do you understand it? Tomorrow I'm going to have an all-day review on anything you need help on.
We already, we had the review.
You have the factoring review that you did? The answers are already up, so make sure you come in with the questions on factoring tomorrow. And then I'm going to put up another review for the 2.1 to 2.3. All this stuff, standard, factored, and vertex. And that's what you're going to practice. And then you'll come in tomorrow with any questions.
Are we doing the review for homework?
Yes, tonight.
Oh, are you doing it?
It will be, no, you're doing the one, you're doing the 2.1 to 2.3 review. I haven't put that up yet.
Okay.
All right. Now, let's talk about this for a second. You don't have to write, I don't think many of you are taking notes, but you don't have to write this. I just need your concept right here. If this is my vertex, and this is another point, what could I do to get another point on this? Mirror it, right? We talked about this right here. If this is the vertex, then this line through here is called the axis of symmetry. And if I go over 1 and up 2, then I'd go over 1 and up 2 over here. Are you with me? What do you notice about these 2 points? There's a couple things you can notice. They have the same exact y value. Are you with me? What else do you notice about them? They're the same distance from the axis of symmetry. Do you follow me? So if this was -2, comma -1, and this is -3, what does that mean this order pair has to be? -4, -1. What do you notice about, what did we say about their y values? They had to be the same. And what did we say about their x values? If this is 1 to the right of this, this is 1 to the left, because the axis of symmetry has to fall in the middle of them. Are you following me? Really big thing to understand here. What happens when I give you factored form? You can find this axis, or this x-intercept, right? You can find this x-intercept. Where do you know the vertex has to fall? Not in between. It has to be dead in the middle of them. So however far this away is, this has got to be equal distance from that, yes? But that's only the what value that I'm looking at. Only the x value. So I'm going to teach you how to find the x, and then what do we always do whenever we find the x? Plug it in and we'll find the y coordinate for the vertex. Are you with me? All right. How do you find the middle of 2 numbers? First, you have to add them together and divide by 2. That's how you find the middle of any 2 numbers. So, start you off with an easy one. Before I can go and attack the vertex, like if someone says, hey, Mr. Martin, what's the vertex of this? I know they didn't ask me for this, but what do I have to find first?
The X-Intercepts.
I need to find the X-Intercepts first, because then after I find the X-Intercepts, I can find the midway between them. So what's the intercept? -2, be careful. And +4. So I know it's something like this. If I was drawing this real quick, I know it'd be -2 and 1, 2, 3, 4. Now, it's not always going to be nice, pretty numbers like this, so we need to learn the math. I can't count. Like, I know you can go 1, 2, 3, 1, 2, 3. Okay, so this is the middle. I can't do that all the time. I have to do the right way to find that. So what did we say? To find the middle of any two numbers, I need to find the middle of these two. We add them together, divide by 2, because it won't always be pretty like this. And this turns into a 2 divided by 2, and 2 divided by 2 is, but that is only the what? It's only the x. So what do I do to find the y? What do I do? Plug 1 in for x. Should plug in using parentheses just to get you the habit of that. 1 plus 2 is? 1 minus 4 is? Negative 3. Negative 3 times positive 3 is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. Boom. Draw my graph. Because I now have my vertex, I know the axis of symmetry. Yes? What is it? Thank you. X equals 1. Is this a max or a min? Look at it. It's like, is there a lowest point that this graph goes to? Yes, it's right here, right at the vertex. So my minimum is -9. Concavity is facing up, by the way. This is where your A value would be. There is a number in front of that. What number is it? Since there's nothing there, it's not 0. It's a 1, but that means it's positive, right? Since it's positive, what way was this graph facing? Up. All the stuff that we've talked about still kind of coming true. Yes or no? I want you to find the minimum or maximum. Leave it as a fraction and do the math. Oh, I know we're going to do a lot of fraction work. Oh, yeah. All right, so if I ask you for max or min, I didn't ask you for the vertex, did I? But in order to find the max or min, what do you have to find? The vertex, because that's where the max or min is going to happen. So, and I didn't ask you for the X-intercepts, did I? But you have to get them. You get what I mean by this, how this kind of works? It's kind of a pain in the butt, but it is what it is. So x equals 3, x equals -2. Those are my two X-intercepts. I'm going to then take those two numbers together, add them and divide by 2, and I get negative, or I get 1/2. I then have to plug those in, and I have to use fraction work. 1/2, and we just need to get used to it. -3 times 1/2. Notice how I'm plugging in using parentheses. I know it seems silly, but it makes a big difference, right? I also am going to take this over to the side. 1/2 minus, instead of 1/2 minus 3, I'm going to think of this as 3 over 1. I'm going to set myself up for success and go, hey, times that by 2, times that by 2. So instead of a 3, I'm going to write a 6 over 2. It's okay to do side work like that. You with me? And then 1 minus 6/2 turns into -5/2. You with me? Same with this one. 1/2 plus 2. Instead of writing it as 2, I'm going to write it as 4 over 2. And that turns into 5/2. Then I end up with multiply fractions, top times top, bottom times bottom. A negative times a positive is a negative. 5 times 5 is 25/4. So my vertex was 1/2 -25/4. Why does that vertex make sense? My intercepts are 1, 2, 3, 1, 2, right? And this is 1/2 and -25/4. 4 goes into that 6 times, yes? A little over 6, so 1, 2, 3, 4, 5, 6, a little over 6. So like right here, why does that vertex make sense? What does that make this parabola face? Up. Which way was it supposed to face? It's supposed to face up. Are you with me? What part? Huh? Okay. Top times top, bottom times bottom. Top times top, bottom times bottom. And then when I do this, what question did I ask you for? The minimum. Where does the minimum happen? This is the minimum, right? So y equals -25/4 is my minimum. That is simplified. That's different. No. Simplifying means that the top and the bottom have nothing common. Changing it to a mixed number is not simplifying it. And the reason I'm telling you that is, in higher levels, we'd rather you leave it as this. Here's the reason why. What's the first thing you have to do with any time you add a fraction with another fraction? And one's a mixed number, and the other one's a fraction. You have to put it back into a what? Improper fraction. What's the first thing you have to do when you go to multiply them? So guess what we leave them as? Because you're going to have to change it back to that anyways when you go to use it. You get what I mean? Now, why did we teach you in middle school? Because you come from middle school and like everything has to change into a mixed number. Why did they make them do that? Because they wanted you to practice doing that, because you don't go to Home Depot going, I need 25/4. They're going to look like you, what? You're going to go, I need 6 full sheets of this and then a half of another one. So we wanted you to practice being able to change them back and forth. But really, as far as math is concerned, we need them improper when we use them. Questions on anything so far with factored form? At least if you can come up with a specific question, I can help you. I mean, if there's like, I don't know where this comes from, then I can help you. Questions on factored? Questions on standard. Questions on vertex. All three of them. And I'm going to ask you for random things. I'm going to give you any form and ask you for a vertex. I'll give you any form, ask you for X-intercept. Any form, ask you for Y-intercept. Any form, ask you for max or min. Any form, ask you for axis of symmetry. Any form, ask you to graph it. What do you only have to get when you graph it? What's the first thing you got to find? Vertex. Then you just make an X and Y chart if you want to. Get a couple points on the right-hand side, mirror it on the left, you're done. Like, it's the same kind of thing over and over again, as long as you get the concept.
Is the test on everything?
No. It's only going to be on 2, 1 to 2, 3, which is factored, standard, vertex. No, we don't have it. We will have the big test at the end of the semester. Once. You can't exempt both.
So you could have done for one at the end of the semester or at the end of the year?
Yes. From my understanding.
I only know this one because if I get like a C or something, I'm getting exempt. You gotta find it.
All right, try this one then.
Just the two in front of it. You only do that for the first practice, right?
Do I, when I'm finding my X-intercept, do I care about that too? Why not?
Because that's just telling you whether it's based on or down.
What is this 2 doing to this bubble? So if this bubble is 0, what's 2 times that 0? Times whatever number this is. So still, when you have it like this, the only thing I care about is what makes this bubble 0, what makes this bubble 0. And at least do you understand that part?
Mr. Martin.
You don't understand that a 6 minus 6?
Janina is waiting in the lobby.
What would be the next one? Thank you. Are a lot of you getting kicked out? Find the vertex. Man, this thing is having a hard time. Yeah, if you ever have a hard time with anything that's going on in class, feel free to, do what you need to do. But if you can't watch it, you can always watch the YouTube video. Can be.
If you got two, what do you call it? X-intercepts, you gotta plug it in separately or the same. I mean, that's how you find the Y-intercept.
You gotta find the middle.
All of it.
When you plug in the axis, you just multiply the numbers.
Yes.
And do that on 1, 5,
Doesn't matter. Hey. It doesn't matter. You can do 2 times 3, and then you can do 3 times 5, or you can do 3 times 5 and then double that. That's called the associative property, or commutative, whichever one you wanted. So when you did this, x equals 6 is your first intercept. X equals -8 is your second intercept. You add those two numbers together, what do you get confused on? You get -2/2, which is -1. You plug in -1 into both X, and then you just solve. You just do your math. So -2, -7, +7, multiply. What's a -2 times a -7? And then 14 times 7. So your vertex would be -1, 98. Axis symmetry, X equals -1. Max or min? Ooh, be careful on this one. 98, but what is it? She said it's a max because it's facing down.
When you are writing like the X-Intercepts, since that X equals whatever, you just write the axis. X-axis equals -1. There's a lot of X equals.
Yeah, so you would define it. So like you would maybe write this axis of sim, like AOS. This right here, I would probably write as 6, 0, -8, 0, or label them X-intercepts. Like the question is going to ask you what they are. So yes, I get what you're saying. Questions? You have a review tonight. Make sure you're going over that. It will be up on Portal.